We're going to have a look at an area in maths in the algebra topic called expansion concepts. Okay, and the first one we're going to look at is called the difference of two squares, and it's within this expansion patterns section. Okay, the difference of two squares, and let's see what we mean by the difference of two squares. Now we have two terms there multiplied by each other. First bracket has x plus 3, second bracket has x minus 3 in it. Now, that actually means the first term in the first bracket times all of the second bracket plus the second term in the first bracket times all of the second bracket again. Okay, that's what that means. Now, I'm going to put some plus signs in front of the terms which don't have a sign so that we can then not get mixed up when we're doing our expansion. Because remember, when we're multiplying terms together, you've got to worry about the sign of them. If the signs are the same, the answer is plus. If the signs are different, the answer is minus. So, now, that's what you get when you expand that. I've got x squared minus 3x, that's a minus because the signs were different, then plus 3x, and then minus 9. Now what happens is, when you clean that up a little bit and get rid of those times signs, the like terms cancel out. And we are left with this arrangement here, which is called a difference of two squares, because x is squared and the 9 is actually 3 squared. Okay, that's what it's called. Now you notice that the x's, the front terms in each bracket, were the same, and the 3's, the rear terms in each bracket, were the same. And one of them had a plus and one of them had a minus. That's how to recognise a difference of two squares expansion. Okay? DOTS stands for difference of two squares, and the middle terms cancel out. That's what you've got to understand. Okay? Now, in general, we have this arrangement here. That's what difference of two squares, how to recognise it. You've got to have an a plus b in one bracket kind of term and an a minus b in the second bracket kind of term, and that yields us a squared minus b squared. So you can recognise them now, and you can just basically not worry about the expansion. You can just come up with the answer once you understand what's happening here. Okay? Let's do another one. Okay, now that looks like a difference of two squares because these terms are the same, those terms are the same, and we've got a plus and a minus. So this is looking pretty good to me. Now let's see, we'll just apply the formula, difference of two squares, and we'll see what we get. That's x squared minus 8 squared. I don't even have to worry about the expansion of it because I know that's what my answer is going to be. Wow, and that's going to be x squared minus 64. So that's pretty marvellous, isn't it? So let's see. Yeah, hey, smiley face, of course, because it's so much fun and it's very, very simple to do. Okay, let's push on. We've got here another example of a difference of two squares, and you can see that the front terms in each bracket are the same and the rear terms in each of those brackets are the same, and there is a plus and a minus in each. One's a plus and one's a minus. So that's the signal. You think, aha, that's a difference of two squares. So I'm just going to use my formula and I'm going to work out the answer. And there it is. It's 2x all squared, the first term squared, minus 3 all squared, which is the second term squared. I'm just writing it out there in full so you can see how to square all of 2x. It's the 2 and the x have to both be multiplied by themselves. Okay, so that comes to 4x squared minus 9, which is pretty neat. Like it. So, that's the end of that one. Let's do another one now. We've got, that looks a bit off-putting. It doesn't look like a difference of 2 squares because the terms in each bracket look to be different, don't they? But are they? Oh, well, what was my little helper going to tell me to do here? Oh, if I swapped that 5 and the 3x, which wouldn't change the value of the first term in brackets, what would I get? Oh, that's better. Now it looks like a difference of 2 squares. For sure it does. So let's just do it. Yes, that's going to be 25 minus 9x squared. That's very good. Oh, Smiley says it's way cool. And it is way cool. Definitely way cool. Okay, so that's the difference of 2 squares thing. Okay, everybody? Now I think we'll move on to the next part of our learning today, which is the expansion of a perfect square. So this is part B of our lesson today. Difference of 2 squares is done, and this is the next section. Okay. Now, what is a perfect square? It means you simply take something such as x plus 3 in brackets and you multiply it by itself or square it. Yeah, that's what you do. Now, let's just have a go at this perfect square expansion, okay? Now, you multiply the first term in the first bracket by all of the second bracket, which we're just doing now, and then you multiply the second term in the first bracket by all of the second bracket, and we're going to do that now. There it is. Now, that's all you do. That's what you do. And let's just clean that up a little bit. Okay, that's cleaned up. Now, I can see some like terms. Can you? Yes, the 3x terms are like terms. So there's 6 of them all told. And that is our expansion of that perfect square, okay? In general, if you have a plus b all squared, it comes out to be, okay, that's the expansion of it. And even when you clean it up and combine the like terms, you get a squared plus 2ab, because the ab and the ba are really the same term. The multiplication order doesn't make any difference, and that's what you get. If you have a minus b all squared, then expanding that out, you will get exactly the same thing, except there's a minus in front of the second term. That's basically in general what these things produce as an end result. So we can just use this knowledge now to just come up with an answer without going through all the rigmarole of expanding them all the time. So in words, what you do, the recipe is square the first term, add the square of the second term or the last term, and then add or subtract depending on what the expression originally is, whether it's all plus or there's a minus in there in between the terms, and you add or subtract twice their product. Now that is the quick way, okay? So let's have some practice. Here we go. Use the perfect squares technique to expand and simplify the following. Here's number A. We've got x plus 1 squared, or x plus 1 times x plus 1. Okay, well, we'll just see what that brings us. We're going to use our formula. And look, we've used it. It's the first term squared plus 2 times the first term times the second term, and then Oh, that should be a plus. Plus 1 all squared. Sorry about that little times. That little times there is a little bit wrong. So I'm just going to make sure, just rub that out and make it into a plus, okay? Okay, I've fixed it. Alright, now, that's right now. So let's keep going. That's x squared plus 2x plus 1. And there we have it, okay? There's the end result of expanding that perfect square. Okay, let's try another one. Now this one's got a minus sign in front of the 2, so we have to be careful with that one. And this is what I like to do. I like to put all of the signs exactly where they go. In other words, I like to put a plus in front of the x, and I like to add the 2 terms, but the 2, I call that negative 2, all squared, okay? And that will help me sort out exactly what to do with it. I'll just rub those out now. Let's take a step further. That's going to be plus x all squared, yes, and plus 2 times the first term times the second term. Now you see how that minus sign gets in there? That's very interesting. That little minus sign really belongs to the negative 2, okay? So let's just go again. Plus negative 2, that should be squared, okay? Negative 2 squared. Okay, now we're just going to clean that up a bit. X squared minus 4x plus 4. My goodness, that's pretty good, pretty exciting. So here's another one. We're going to try this one now. This one is 2x plus 5 all squared, okay? Now both terms are pluses, so we don't have to worry so much about the problems with minus signs. It's all going to be plus. So that's the first term squared plus 2 times the first term times the second term plus the second term squared. And what do we get? 4x squared plus 20x plus 25, okay? So that's how it all works. It's pretty good, isn't it? And we've got a little smiley face over here for you to let you know how excited we're all getting about this new technique that we've just perfected. So, I hope you got something out of that, and it's not a problem. It's just using the formulas that you get and just applying them carefully, and you won't go wrong. Okay, see you next time.